friends, welcome to another video. We're going to be talking about the factoring set of notes, or section 4 of chapter R. We're on page 2, multiplying and dividing polynomials. Factoring polynomials is just like factoring real numbers. So again, I talked about in the last video factoring, grouping, division. That's the idea. 35 can be factored. It says air quotes factored. It can be factored as 5 and 7. But it can also be factored in other ways because you can divide 35 in other ways. When we talk about factoring, really what we mean is factoring generally. We mean factoring without fractions. Now, I'm going to say generally. There are a few circumstances where you want fractions and you're okay with that. But really what I want you to focus on is the goal is to get it without fractions. So 35 can be factored as 5 and 7. You can also factor it by 2, but you get 17.5. That's not what we want to mess with. So we're doing it without fractions, without decimals. It can also be factored with 35 and 1. So again, there's options to go down and there's options to think about as we move forward with this. Negative 8 can be factored as negative 2 and 4. When we multiply them back together, again, factoring is like division. To undo it, we would then multiply. So to multiply 5 and 7 gives us 35. Negative 2 and 4 gives us negative 8. And we also do the same with polynomials. So the idea here is that we're taking something that's chunked together, grouped together, that's more difficult. By factoring, we're actually making it easier to do something else. So I want you to get in this mindset of factoring helps us prepare the problem for the next thing. So factoring in of itself may seem difficult up front. What you're doing is you're making the problem, more manageable, bite-sized, if you will, so that you can then approach it differently later. So the idea here, x plus 1 times x plus 6, when we multiply together, it gives us x squared plus 7x plus 6. And then when we factor, or again, here's the division, divide out, we get x plus 1 times x plus 6. And we can do things with x plus 1 and x plus 6 a lot easier than we could do with x squared plus 7x plus 6. So the idea here is that we're breaking up into pieces or chunks, and then we can do things with these chunks. This says multiply the following together, pay attention to the patterns and signs, use FOIL, use whatever you want. Really what I want you to focus on is the patterns and the signs. Patterns and the signs. So if I multiply x plus 3 times x plus 2, I get x squared. And then plus, I know that this is going to be plus. We'll talk about that more here in a bit. And then I'm going to have 5x. And then plus 6. Now you may wonder, how did I do that so quickly? How come I got, 5x? I must be looking at the answer key. No, although that could be the case. Really, what's happening is I see that I'm taking 3x and 2x and adding them together. That gives me the 5x. Similarly, I have x squared here. Ooh, now their signs are not the same. I have a sign that's different. So I'm going to take 3x minus 2x. That just gives me plus x. And then a negative 6. I'm going to see some patterns here soon. The next one's very similar, except the minus sign's with a 3, so this gives me x squared minus x minus 6. Interesting. And then this gives me x squared, and then here I have minus 5x, and then plus 6. So really what I want you to focus on is what's happening with the signs. So if I start out with a positive, then what I'm going to end up with are two factors that are positive. If I start out with a negative and positive, then what I end up with are two factors that have the minus signs, or that are negative here. And then here, I have a positive and a negative, positive, negative, 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 positive. Oh, that's a little bit weird. We'll have to see that here in a bit. Factor the following, refer back to what we just did for help on the signs. X squared minus 9, so x squared minus 9 is actually a difference of squares. So when we have x squared minus 9, we're going to have x plus 3 and x minus 3. So this is one of each. That's kind of weird because we're not seeing what's going over what's going over with that. And I want you to think about here that I have x squared plus 0x minus 9. So let's think about that one for this one. So move on, x squared plus 9. Wait a second. That's not a difference of squares. You haven't learned that, and you didn't learn that in Algebra 2 until we got to the real number, the imaginary numbers. This is actually a non-real answer. So it says write prime. So I'm just going to write prime there to show, hey, That's prime. The next one, x squared plus 6x plus 9. You may know that as x plus 3 and x plus 3. And then this last one is x minus 3 times x minus 3. So let's kind of generalize this into some sort of pattern if we can. If the last term is positive, so if the last term is positive, what's going to happen with our numbers? So if the last term is positive, it says you have two of the same signs. So if our last term is positive, whatever this is here, then what you end up with is either positive positive, if this sign here is positive, or negative negative if this sign here is negative. And if I go back up here to when we did this example, you can kind of see here we've got this being positive. And because that was positive, it's kind of hard to see this blue as a different color. Let me grab one that's more strikingly different than this green that I used initially. Let me see how purple looks. So it's one of those situations that in real life it's a lot easier to tell, but because of the camera it's kind of difficult. So you can kind of see a difference. So that's plus, and because that's plus and we have a minus sign here, then both of our signs are going to be minus. And this is plus. Because we have a plus sign here, and we have a plus here, then both of our signs are going to be positive. Plus, plus. And now, differently is when we have a negative sign. When we have a negative sign here, that it really doesn't matter what our first sign is. We're going to have one being positive and one being negative. And that just has to do with, how the opposites, when you add them together, which one is larger in magnitude. Magnitude is the distance from 0. So we'll talk about that as we move on. Just know that when you have a minus sign here, then it doesn't matter what the first sign is. It's going to be one positive, one negative. And that's what I say down here. If this last term is negative, then we just have two different signs, and that's that. So multiply the following and look for patterns and signs. So let's see what happens here. So 2x times 3x, I'll give you the answer, 6x squared. 2x times 4 is 8x. 1 times 3x is 3x, so that's going to give me plus 11x. And then the last term, plus 4. So when I have a positive and positive, I multiply them together to get, a positive and positive. Here, 2x times 3x, I'm going to have a 6x squared. And now I have minus 8x plus 3x, so that's minus 5x. And then 1 times negative 4 is negative 4. So again, if I look at this sign here, because this is a minus sign, that's what gave me one of these being positive and one of these being negative. Here I've got 6x squared. Kind of noticing a pattern in this first one, it's all going to be 6x squared. The last term is always going to be 4, it's just my middle number is changing and the sign in front of it's possibly changing as well. 2x times 4 is 8x, minus 3x, this is plus 5x. And then minus 4. So again, minus sign here, one's negative, one's positive. If you think about it, the only way to get a negative here is to have one of the factors being negative and one of them being positive. And then this last one here, again, 6x squared to start out with. And then I have, let's see, that's negative 8x, so that's minus 11x. And then here, plus, because a negative times a negative is positive, plus 4. So because this is a positive here, then this sign here told us what signs both of those were. And the similar happens with this as well. So x times x is x squared. You have minus x, and then minus 20. The next one is x squared minus 9x plus 20. X squared plus 9x plus 20. And then x squared plus x. Minus 20. So again, verify that this pattern that we have over here, verify that the pattern is correct for this as well. Look forward to seeing you in the next video.